In question 3, we start off with our analytical geometry. We've been given the following diagram with 3 coordinates, and we need to determine the gradient of the line MQ. So in grade 11, there are 5 ways to determine gradients, but if I have 2 points on my line, then I can simply just use my gradient formula. And it really does not matter which order you put the points in. I like to put the top point in first. So I'm going to put -2 and 0 into y2 and x2's place. And just remember the y value goes on top. So that 0 will go on top here. And the -2 will get filled in at the bottom because it's an x value. Now let's chuck our pink point in. I'm going to put the -2 on top because it's a y value. And the 4 will go to the bottom because it's an x value. Now ain't nobody got time for that, bruh. That's going straight in the calculator. Okay, so we're going to slap that in and we get -1/3 as our gradient. And at the same time, I like to put that on my sketch. It really helps you with later questions. And we can see from left to right, this graph is going downhill, so a negative gradient makes perfect sense. In question 3.2, we need to find the equation of the line MP in the form y equals mx plus c. So I'm going to represent MP with this orange over here. And let's analyze what y equals mx plus c is all about. So the letter M is representative of your gradient, and the letter C is representative of your y-intercept. And if we go to that orange line, oh my gosh, look at that. There's the y-intercept. So let's pop it in. Simply just by changing this C to a 6, like this. Okay, now we need to get M. So how I can get M is I can use the gradient formula between these 2 points, or I can simply just substitute a point in. I'm going to go the second route and substitute a point in. And to choose the point to sub in is a little bit tricky. We've kind of already subbed this in by placing the 6 there, so we have to choose the letter or the coordinate M to sub in. And then when I sub in, just remember the first one goes into X's place and the second number goes into Y's place. So let's go ahead, make that switch, and now all that's left to do is solve for M. So what I'm going to do is I'm going to take the 6 over to the other side. It becomes -6, and -2 times M will give me -2M. I divide both sides by -2, and that will give me a gradient of +3. It makes so much sense because this is going uphill. So now we're going to put that 3 back in here to finalize the equation for MP. So let's chuck him back in quick, and we get y equals 3x plus 6 for the equation of MP. And your 3 marks will be awarded for substituting in the correct C value, doing the correct substitution, as well as the correct final answer. And for question 3.1, you get 1 mark for your substitution and 1 mark for your final answer. A good tip for analytical geometry is all your previous answers, put them on your sketch. It really helps, and make your gradient stand out a little bit. I know the gradient of this line is 3 just by looking at the number in front of x. And now we need to determine the coordinates of R. R is situated all the way on the left over here. And what I'm noticing about R is that it's the end point for a line that we have the midpoint for. So we've got the end point and the midpoint, and we need the other end point. And also I'm missing 2 variables. I'm missing an x and a y, and that's a kind of giveaway that I have to use the midpoint formula. Now when I'm getting an end point, I split the midpoint formula up into 2 separate formulas, one that deals with the x values exclusively, and another one that just deals with the y values. So we're going to use the bottom formula, not the original midpoint formula that's on the formula sheet, the split up version which is not on the formula sheet. And now we're just going to simply fill everything in and solve for the missing variable. So the x in the middle, or the midpoint, is -2. So I'm going to change this to -2. And then x1 and x2 are the x values at the end. So that's going to be 4 plus, and I'm just going to name this xr, the x coordinate that belongs to coordinate r. So let's go ahead and change those top two. Okay, and then while we're here, let's do the same thing for the y values. The y value in the middle is 0, so I'll replace this with a 0. And y1 and y2 are the y values at the end, so it's this minus 2 over here and the yr, so it's just going to be minus 2 plus yr. And now that everything's filled in, we just need to solve for x and y. So over here I'm going to cross multiply that 2 up there, and it will give me negative 4. And then the top remains unchanged, so this will just equal to 4 plus xr. Now I'm going to move that 4 over, it becomes negative 4, and I get negative 8 as the x value for r. So now we know half of the coordinates of r. It's negative 8 and something. So let's go ahead, repeat that process for the y's. So we're going to multiply that 2 up with the 0. 0 times 2 is just 0. And the top will remain unchanged. You just have minus 2 plus yr. I'm going to grab this negative 2, move it over there, and it becomes plus 2 when I move it over the equal sign. So now we know the y value for r, and our job is officially done. And having a look at the marks, substitution earns you your first mark, and each respective x and y value gets you the second and third mark. And just remember to transpose your answers on the sketch, put them on the sketch. Next up, we need to calculate the length of PQ in simplified third form. So length is an acronym for distance. So we shall use our distance formula to calculate that. It's pretty stock standard. We're just going to pop our 2 points into the distance formula to get the length. And we've got to put any coordinates, it doesn't matter which one I start with, into the purple guy's place. I like to start with the top one. So I'm going to put this 6 into y2's place and this 0 into x2's place. And then the other coordinate slots into x1 and y1. So I'm going to put negative 2 into y1's place, and I'm going to put 4 into x1's place. And just remember, if you have negatives, to wrap them in brackets. Okay, and then we're just going to slot that in the calculator. That is a calculator problem, not ours. So Uncle Calculator tunes us, it's 4 root 5, and we've got to leave our answer in simplified third form, so we just leave it like that. The square root is the third that they are referring to. So PQ has a length of 4 root 5 units. And just in case you're curious, that's about 8.94. And your 2 marks will come from your subs and your answer. In question 3.5, we've been told that RPQT is a parallelogram, and the coordinates of T are somewhere in the third quadrant. So let's just go through which quadrants are which quickly. So this over here is quadrant 1, and in the top left corner is quadrant 2, and the bottom left hand corner is quadrant 3, and lastly in the bottom right hand corner we have quadrant 4. So the fourth point of our parallelogram will lie somewhere in quadrant 3 for this question, as they told us here. So it's going to be like somewhere down there, and the parallelogram will look something to this effect. And the coordinates of T will lie somewhere down here. Now we're going to analyze our gradients to pull this off, like so. So whatever I do to get from this point to this point, so however much I go down and across is the same as what I'm going to do to go from this point to this point. So I'm going to go down the same length and across the same length to get to T. So let's see how much we go down. We're going from 6 to negative 2, which tells me I'm going down 8 units. I have to go down 6 to get to the x-axis, and then I have to go down another 2 to get down to negative 2. Or you can say top minus bottom. 6 minus minus 2 will give you positive 8. So that means I'm going to go down 8 this side. Now let's analyze how much we go across. To go from 0 to 4 must be 4 units. So on this other side, I'm also going to go across 4 units. Okay, now with this we can get t. And to get the x value of t, we exclusively look at the x value and the horizontal movement. So I'm going from -8, 4 units that way. It will take me to -4 because I'm adding 4. And then if I go down 8 units, I only look at the y value. So 2 minus 8 will give me -6. And now we officially have t to be -4 and -6. And you'll earn 1 mark from your x value and 1 mark from your y value. In question 3.6, we need to explain why RPQT is a rhombus. So RPQT, they told us in the previous question that it's a parallelogram. So the deciding factor that changes a parallelogram into a rhombus is if the diagonals are perpendicular, and they are. So that's exactly our reason. So if you have a parallelogram and you see a 90-degree here, that automatically makes it a rhombus when the diagonals of a parallelogram are perpendicular, because that is the crucial difference between them. We can also prove that adjacent sides are equal, but that's a very long way around, especially for 2 marks. And you'll simply be awarded for one mark for the diags of a parallelogram. That word has to be there. You cannot say quadrilateral. And the second mark comes from saying are perpendicular. In question 4, we continue with analytical geometry, and we've been given the following diagram, and we've been given the equation of AC. It's quite a weird one, but let's transpose that information onto our sketch and let's get busy. So I need to determine the coordinates of C. So if I look at the green line, C is a very special point. It's the y-intercept, my China bean. Okay, and what do we know about the y-intercept? We know that the x value is 0, and if we want to solve for it, we let x equal 0 and then solve for y. So we're going to do exactly that. We're going to grab the equation of AC, replace this x with a cheeky little 0, and then we solve for y. Now to get y on its own, I need to do the following steps. I'm going to move this minus 5p over to the other side. And py minus 0 is just py. It's like saying 7 minus 0 is just 7. So I get py equals 5p. And now the end mission, I need y on its own. So I need to get rid of the p's. And I'm going to do that by dividing both sides by p's. The p's on the left hand side will cancel with one another. These p's will also cancel with one another, leaving us with a y value of 5. And now we know the coordinates of C will be 0 and 5. So we just need to state that just by writing it somewhere in our answer like this, and then we've officially wrapped up the question. And our 3 marks come from making x0 our manipulation as well as the final answer. In question 4.2, they tell us that the gradient of AC is 1/2, and with that we need to show that P equals 2. So I'm not allowed to use this p equals 2. I've got to show where it came from. So my first instinct was basically to sub this point into that line to get p. But that was unsuccessful because it just gave me 5p equals 5p. So I've got to find another way around. So I'm focusing my attention to this point here. I know a little something about that point there. I know its y coordinate is 0 because it's an x-intercept. And now if I have the gradient of this line, I can get this missing point by just utilizing my gradient formula. If I have 4 of these guys and I need a 5th, it is possible to solve for the 5th. So the gradient, I'm going to change it to 1/2. And then for my first coordinate, as you know, I like using the top one. So I'm just going to pop that 5 into y's place, and that's 0 into x's place. And now let's pop in the other coordinates on our line. It's this purple one over here. So the 0 will go on top, and the x value for coordinate A will go at the bottom. And now I'm just going to solve for x over here. So at the top, 5 minus 0 will just give me 5. And 0 minus xa is just minus xa. It's like 0 minus 7 is minus 7. And now I just need to cross multiply to get rid of the fraction. So minus xa times 1 is minus xa. And 2 times 5 will give me 10. And then this negative, I transfer it to the other side. I basically divide both sides by negative to get rid of it. And now we know that the coordinates of A is minus 10 and 0. Now we can kind of return to our original mission and take this point and sub it into that equation and solve for P. So we're going to grab that equation and we're going to change x to minus 10 wrapped in a bracket because there's a minus in front. And we're going to change this y to a 0. P times 0 is just 0. Minus 10 is positive 10. And the minus 5p can stay where it is. Then I'm going to yoink that over to the other side. And it becomes positive 5p. Divide both sides by 2. And 17 years later, we have p equals 2. So now, they didn't quite ask you to get p. What they're more so asking you is to complete the equation of AC. So what I like to do is this P, I'm going to replace it with my answer like this. And then I reorganize it. So 5 times 2 is 10. And then I move that minus 10 over. And I move that minus x over. Divide everything by 2 so that the standard form of my line appears. And I can read off the gradient of my line, as well as the y-intercept of my line. Okay, and the slag means I only award 2 marks, one for A, one for P. In question 4.3, we need to calculate the coordinates of B. So let's have a look at B. We're missing x and y, so I'm missing 2 variables. So I'm going to need 2 equations to solve for those 2 missing variables. So I've got the first equation here. From the previous question, we know the equation of this line is y equals a half x plus 5. But I don't have the equation of the blue line. I need the 2 lines that touch B, that intersect over there, so that I can apply the following rule. To get the points of intersection, I can make the 2 graphs equal to one another and solve for x. But I don't have the equation of the blue graph, so we're going to have to go on a side mission to get it. And we're going to do it with our classic y equals mx plus c. And then I see a 90-degree angle over there, which will enable me to calculate the gradient of the blue line using my perpendicular lines formula. So let's go get the gradient quickly. So I'm going to put in the gradients of the green line here, because that's the one that's perpendicular to the blue line. The gradient of the green line is this half over here. So let's chuck him in. And then minus 1 divided by half will give you minus 2. And the honorable calculator agrees with me, you see? Yes. And just another thing, you can change like M2 to MBD. You can state the line that you're getting the gradient for. Okay, we're going to take that gradient, slap it straight into y equals mx plus c, but... And now I'm going to start hunting for that y-intercept. Do I have the y-intercept of the blue line? Hey, how's it? But minus 10, yes. So we can replace c with minus 10. And now we officially have the equation of the blue line. And now that we have the equation of the blue line, we can jump back into our original mission from earlier, where we're going to get the points of intersection and make the equations of the 2 graphs equal. So I simply just do that by grabbing the equation of the green graph, half x plus 5, equals the equation of the blue graph, minus 2x minus 10, just like this. We make them equal and we solve for x. So we're going to get all the x's to one side and all the numbers to the other side of the equal sign, because it is a linear equation. So when I move this 2x over to that side, or the minus 2x, it becomes positive 2x because we're moving it over the equal sign. So we're going to get a half x plus 2x. I'm going to ask my calculator to help me out there. And you just type it in without the x's. So you can see there, half plus 2 gives me 5 over 2. So on this side of the equation, I'll get 5 over 2x. And if I take this 5 over, it becomes negative 5. Minus 10 minus 5 will give me minus 15. Then I divide both sides by the number in front of x. Just make sure when you type it in on the calculator, you say minus 15 divided by a fraction like this. And then that's going to give us negative 6 for the x value. So we're almost there. We now know that b has an x value of negative 6. To get the y value, I simply substitute that negative 6 into the equation of either graph, because it lies on both graphs. I think this graph looks easier because there's no fractions, so I'm going to sub it into the blue graph. And all that entails is changing this x to a negative 6, just like this. Okay, then we're going to slide that into our calculator, and it returns us y equals 2. So now we know that the full coordinates of b are negative 6 and 2, and that makes so much sense. B is in between an x value of 0 and negative 10, so negative 6 fits in that criteria perfectly, and the y value will have to be in between 0 and 5, and 2 fits that criteria perfectly. So we're in the right regions and things are looking good. In this question, you get 4 marks from the following steps: the equation of BD, the substitution, the x and the y value, and the 5th mark will come from this step that we did previously, where we put p in here to get the equation of our green line. In question 4.4, we need to determine the size of alpha. Alpha is an angle that's down here. Anytime I want to get angles in analytical geometry, I need to use my angle of inclination formula, which is m equals tan theta, m representative of the gradient, and theta is representative of your angle of inclination. So if I have an increasing line, it's just from, you basically go a little bit right of your line, and then you go anti-clockwise till you touch your line. So if I demonstrate it with this line, I'll go a little bit right, go anti-clockwise till I touch my line. So alpha is in fact the angle of inclination for the green line. So we can just put the gradient of the green line into this formula straight away and solve for the angle of inclination, which is alpha. So let's make those changes. So we're going to change the gradient to a half, and we're going to change the angle of inclination to alpha because they've named it alpha. And then to solve this, we can ignore the special rule. My gradient is not negative, so we do not have to add 180. I'm going to break the tan up from the angle and move the tan over to the other side, and it becomes shift tan. And then that alpha equals, I'm just going to move it to this side to make my life more convenient. And then we just pump that into our calculator, bro. Okay, so when we pump that in, we've got to round it off to 2 decimal places. So if it's 5 or more, you let it soar. If it's 4 or less, you let it rest, my bro. So this 5 will round that 6 up, and we get 26.57 degrees for alpha. Tasty, but. And your 2 marks will be awarded for the correct substitution as well as the answer. In question 4.5, hence means use your previous answer. We calculated this angle in the previous answer to help us prove that ABOD is a cyclic quad. Yes, how did Euclidean sneak its way into analytical geometry? Okay, let's go through the 3 ways I can prove a cyclic quad. So I can firstly prove that the opposite angles add up to 180. I can prove that the interior angle equals the opposite exterior angle of a quadrilateral. Or I can prove that I have equal angles in a bow tie and then it's converse angles in the same seg. If we have a quick look at our diagram, I am seeing a bow tie if I draw this imaginary circle. Let me demonstrate. So I've drawn the imaginary circle that they're asking for in grey, and then the bow tie will be this red guy here. Let me delete those 2 lines so you can see the bow tie even better. And I knew to use the bow tie because of this word, hence I want to incorporate my previous answer. So now I want to solve for beta, prove that these angles are the same, and then I can leap to my conclusion that this grey circle is a cyclic quad. So let's see how we're going to do that. We're going to need to get beta. So we're going to make use of our angle of inclination formula. So let's have a look at our formula. We've seen it before. Gradient equals tan theta. So if I look at the blue line, my angle of inclination, I find the x-intercept, go a little bit right and then anti-clockwise. So I find my x-intercept there, a little bit right, and if I go anti-clockwise, that will be the angle of inclination for the blue line. So let's go ahead and get it quickly. We're going to use that to get beta later. So the gradient of the blue line is -2, so we're going to put that into the gradient place. And then I'll just leave this as a theta. It's representing this arbitrary angle here. There's no other theta, so there's no name clashes. Okay, I'm going to take the tan over, it becomes shift tan. And we are also going to see this small rule come into effect. Do you see how my gradient is negative? So in this line here, I've got to add 180 degrees. So that gives me the true angle of inclination. Okay, let's opgepomp that into the calculator. So Dr. Calculator returns us 116,57 degrees. So now we know that this angle is 116,57 degrees. Now, we're going to use that to get beta with the following triangle. So with this orange triangle, this corner of the orange triangle is 90 degrees. Every little corner on the Cartesian plane is 90 degrees. And then this angle over here, if I just had to extend this line of the orange triangle, we can a bit more clearly see that this 116,57 is an exterior angle of this orange triangle. And basically, to get an exterior angle, you add together the two opposite interior angles. So 90 plus beta will equal this 116,57. So it stands to reason that beta will be equal to 116,57 minus 90. And if we just pop that into the calculator, we will get the exact same size as alpha, which is exactly what we were expecting, 26,57. Now we can see that bow tie, but check it out, bruh. Check how those angles are equal, man. Yeah, bruh. And then all that's left to do is we've got to state that alpha is equal to beta. And then we can make the conclusion that ABOD is a cyclic quad. And the reason is converse angles in the same seg. And in this question, beta gets you a mark, your reason gets you a mark, as well as the size of this obtuse exterior angle of triangle. And rounding out question 4 with question 4.6, we need to get the coordinates of the center of a circle which passes through D, B, and C. So your circle will pass through D, B, and C. And if I want the center of that circle, I'm going to have to utilize this 90 degrees. I've got to follow that 90 degrees back and back some more so that I actually know where the diameter is on the circle, because I'm following the Euclidean geometry theorem that states that if I have a 90 degree angle on the circumference of a circle, I can follow that back and it'll take me to a diameter, converse angles in a semicircle. So now that we know this is the diameter, we can simply get the halfway point of that line, and that's the center of our circle. So we're going to use the midpoint formula, but... And let's decide what version we're going to use. I am getting the midpoint. I'm getting the points in the middle. I have the two end points. So I'll use the first easy version. Okay, let's chuck in our x values. x1 and x2 are just the x values at the end. Crispy 0 and 0. Okay, let's have a look at our y values next. Just simply add the y values together at the end. So it's 5 plus -10. And just don't forget to wrap negative numbers in brackets. And then we're going to slap these two separate calculations on our calculator. 0 plus 0 is just 0. 0 divided by anything is just 0. Okay, and if we chuck this into our calculator, it turns us -5 over 2. But alright, and now we are done. That is the center of the circle that they are referring to. And you're going to get a mark pop, one for x, one for y.